Hello everybody, today I'm going to present the solution to the first problem of the 2025 USACO February contest in the bronze division, and the problem is reflection. In this problem we are given an n by n grid of cells, and for each cell we have either a dot or a hashtag there, and we are described the process in which we have a smaller grid in the top right section of the matrix, and after reflecting it across to the left and downwards, as you can see in this drawing, we get four grids that are identical, the only difference being that they are mirrored on each of the four sides as I mentioned. And we are also told that during various points Bessie has modified certain cells and didn't keep the symmetric structure around, and we want to be able to find after each operation, after each update operation, because in the problem we are told that some cells become different, like they mentioned here that Bessie changes the value of some cells, and we want to be able to tell how many cells we have to modify in order to return to a symmetrical structure. So again, uh, very important to keep track of these changes and to make sure that we are consistent as far as finding the answer goes. Now, in this sample, we start with a 4x4 grid, and basically at the beginning we would have 4 cells, then 3, 2, 1, depending on how updates go. And the same thing goes, they present here a bunch of updates, and that's how they got to the answer. So now the question is, let's try to understand first what we need to do. So let me start by drawing a grid, let's say a smaller grid like they have, a 4x4 grid. And when we draw this grid, I want to emphasize on the goal we have for this problem. So as we see here, if we have a cell, let's say that this cell is a hashtag, but it doesn't even matter that much. Now we want for this cell to find the 4 symmetrical positions to which it's related to. And in order to do that, there are many techniques of doing it, but basically if we have a cell ij, so if we have a cell ij, then in order to get the other 3 symmetric cells, we need to look first on the same line, but on the opposite side in terms of columns. So if we mirror ij, I will assume that we are using 1 indexed here. So if we are mirroring ij on the column, then we will still keep the same line, but the column will become n minus j plus 1. So again, in this case, this hashtag would be replaced with something here. Not replaced, but this cell here is connected to this other cell here. And this is one cell. Now we need to get 2 more of these. Now, very similarly, we can also have the same logic for the rows. So we want to keep the same column, but we want to have a mirroring process on the rows. So again, very similarly, instead of row I, we will have n minus I plus 1. And the number of the column will stay the same. So the column will be j. Now, very importantly, we want to also find the symmetric cell on the corner, because this symmetric cell will help us with completing the 4 cell structure. And now, in order to actually find this cell, this fourth one, it's actually easier because we can just combine the 2 rules we got from the previous cells. And let me also even use another color, even though they are all in the same structure. And actually, in order to get to the red cell, which I just added here, then we need to invert both the row and the column. So we will have n minus I plus 1 and n minus j plus 1. Now, we can find very similarly also other structures like that. We can think of these 4 cells as one such structure, or even if we go with some other color, if we use something like pink, then for example even these 4 cells are together and so on. Now, the very important question which comes into play now is how do we use these connections in order to be able to answer fast to the various operations we are given. And actually, in order to do that, we don't need to complicate our life too much, because all we have to do is at the beginning, we can go over the cells from one of the corners. In my code, I chose to go over the cells from the top right corner. And for each cell from the top right corner, I found the 3 symmetric cells. And basically, when we have a group of 4 cells, we want to know how many hashtags we have and how many dots we have. And in order to make that part of the image symmetric, we have to either make them all become hashtags or make them all become dots. And it turns out that in order to do that, we want to see which one of the 2 goals is closer to achieve. Because if we have more hashtags than dots, then it makes sense to modify the dots so that they become hashtags. Otherwise, we modify the hashtags so that they become dots. And as you see, we can pretty easily pre-compute the answer for the first query, so before we even have any updates. And that can be done in a linear traversal, linear with respect to the size of the grid, so the actual complexity would be n squared. Now, in order to perform an update, we can use a very similar logic, because every update only modifies a single cell. And because every update modifies only a single cell, all we have to do is to look for that cell. So let's say that we change yet again another one. So let's say we change this one. Look at the 3 other cells in the same structure with it, according to the rules I mentioned here. And subtract at first how much we added to the answer based on these 4 cells. Perform the change and then add back to the answer whatever we had to subtract. And with that being said, now all we have to do is for each query to compute these changes and to then return the answer and perform the operations. Now I'm going to show you the code. Now, as you see in this code here, here I started with reading the input, and for each cell in my code, as I mentioned earlier, I chose the top right corner. I have this function which computes quickly how many cells we need to modify on the group which contains the row I and column j. And as you see here, I have the 4 points we care about. The current one, symmetric on the row, symmetric on the column, as well as symmetric on both the row and the column, the mirrorings. And for each of these 4 points, I count the number of hashtags as well as the number of dots. And as you see here, the answer can be retrieved by counting how many A's and B's we have and returning the minimum. And as you see here, when I do this, I keep track of the initial count. And in order to avoid a lot of unnecessary casework, I first subtract the number of updates we had on that region with 4 cells, perform the change, and then add again whatever answer we got. And now, as you see, this code, after performing the pre-computation, actually becomes very easy, because besides having to read the input and print the outputs, the only thing we have to implement is really the process in which we compute the number of changes, as you mentioned. As you see, for this problem, it was very important to simplify the question to just dealing with each of the regions, each of the 4 cell regions. And for each of these regions, find how many changes we have to perform in order to get to the answer. If you enjoyed this video, please like it and subscribe to the channel, and to make so that I can make more videos and that I can make more USACO videos as the season progresses, as well as for the remaining problems from the other divisions. In addition, if you have any sort of feedback or suggestion, please link it in the comments and I will make sure to answer to it and to use it in order to improve my future videos. Last but not least, if you or someone you know is interested in working more closely with me in order to improve their USACO results for the rest of the season, as well as looking forward for the next season, please check out my links in the description for ways to both see the solutions for all bronze problems and also other problems, as well as my website for ways to join my tutoring program. Until the next time, good luck for the rest of the season and see you next time. Cheers.